Thank you for tuning in today for a webinar on the topic of database language standards, SQL and GQL. My name is George Lawa, and I'm the Program Associate of the Institute for International Science and Technology Policy of the George Washington University's Elliott School of International Affairs. It is my pleasure to introduce our speaker today, Mr. Keith Hare. Keith Hare is the president of JCC Consulting, a database consulting company specializing in high-performance database systems, database administration, and data replication and migration. Since 2005, Keith has also served as convener of the committee responsible for the SQL and GQL database language standards, also known as ISO IEC JTC1 SC32 WG3 database languages. Thank you for being with us today, Keith. The floor is yours.
Thank you, George, and welcome all. George gave you most of this, but basically I'm a database geek. I have been doing databases for a long time, high performance databases. I ended up getting involved in the standards process in the US and then the international standards process for the database language SQL because it was interesting and I thought it was fun. It's possible. Some people claim that I have a weird sense of fun, and this could be true. Also, for several years now, I've been working on a project with a JCC client, a company called Neo4j, where I'm working with the language standards and research team, and my tasks working with them are an extension of the standards work that I've been doing, working specifically on GQL strategy and developing the standard. So what I want to try to address today is a quick introduction about what a standard is. It's possible that not everybody who's listening to this has familiarity with exactly what standards are. And so I want to give you a couple of examples and talk specifically about two database language standards, SQL and GQL, and then talk about where the overlap is. So what's a standard? Essentially, standards are agreements between participants on how to do something. You can go into a lot of detail, but the real answer is that standards somehow make it easier and cheaper for businesses to cooperate and compete. So a couple of examples. Well, standards organizations. The beautiful thing about standards is that there are lots of them. There are a number of standards organizations. The organizations that I work with are the ISO, the International Organization for Standardization, and IEC, the International Electrotechnical Commission. And we'll come back to that in a little bit. But there are also things like IETF that specifies how the internet works, IEEE that focuses on electrical and electronics, ITU is telephones, and the World Wide Web Consortium, which is you probably accessed something today using a web browser. Okay, so here's an example. You've probably all seen shipping containers. These are defined by an ISO standard, 668, if you care, and it provides the standard dimensions and ratings for shipping containers. And the benefit of this is that it reduces the cost of labor to load and unload the ships, reduces the cost of shipping goods worldwide. So you can load a container someplace in the world, put it on a ship. It can go someplace else, be put on a truck, be put on a train, can easily be transported. And because it's a standard size, standard dimensions, actually there's a couple of different variations of it, but standard size, it makes it cheaper to ship goods worldwide. Another example, wireless networks. This is an IEEE standard 802.11 that specifies wireless internet access. It's entirely possible that you're listening to this through a wireless network. I mean, I'm certainly presenting it across a wireless network. And if you look at the history of 802.11, there are revisions, 1997, 99, et cetera. And there is a new one, 802.11be, that's scheduled to come out in 2024. The point of this illustration is that standards can be revised, can evolve over time. Another couple of standards, database languages, database language SQL and the database language GQL. So let me talk a little bit first about SQL, then I'll get into GQL. SQL has been around for several years, and I'll come back to that. It describes the syntax for dealing with a relational database, which is representing data in tables and columns. It includes a data definition language for defining the data, the way the data looks, what the table looks like, altering it, dropping it, data manipulation. You can have multiple tables in the schema, multiple tables in the query, and there's a concept called transactions. The important thing about SQL is that it's non-procedural. That is, you tell the database what to do, not how to do it. So there's lots of work that goes on in an SQL implementation, an SQL product, to take a query and execute it as quickly as possible. But as a user, as a developer, you don't have to worry about that. That happens behind the scenes. Quick example of what a database, SQL database might look like. The syntax to create data is I create some columns and I give it some data types, and I can have rules about what it means for the data to be consistent. So in this case, I have a constraint that I'm going to call employee's primary key, and it makes sure that the employee ID uniquely identifies all of the records in the employees table. I can insert data, I can select data, I can update data, I can delete data. And the queries here are fairly simple, but they can get relatively complex. But this isn't an SQL seminar today. Transactions. The idea of a transaction is that I start a transaction at some point, I do some work, and then I say, yep, I want to keep that, so I commit the transaction, and it's permanently saved to the database, and those changes are visible to other users. Or I say rollback, and things are undone. So I can do things in the unit of work. Once I actually commit it, it's there. There's a lot of other work that has to be done to make sure it's permanently there, but when I commit it, the data is there and is available to other users. You might have heard of some of these database products. There's a lot of them. Oracle has their mainstream RDBMS and a number of other products, Microsoft SQL Server, a couple of open source products like MySQL, PostgreSQL, MariaDB. IBM has something called DB2, et cetera, et cetera, et cetera. So the SQL implementations, these are all SQL implementations. And so because of the standard, the syntax that you use is not perfect, but is done very similar between the different products. You do have dialects, but they generally follow the standard. You can get into lots of debates about how difficult it is to move applications from one SQL database to another, but it's much easier to move SQL programmers to a new database product. And I claim, without any actual numbers, but I believe that significant portions of the world's data are in SQL databases. And significant portions of the world's economy are managed in SQL databases. So the SQL products are based on an international standard. And I rattled off, and George rattled off a bunch of letters and numbers earlier. The Database Language Committee is called Working Group 3, and it's a working group of a committee called SC32, Subcommittee 32, which is responsible for data management and interchange standards, which is a subcommittee of a Joint Technical Committee 1, which is a joint technical committee between two standards organizations, ISO and IEC. And JTC 1, Joint Technical Committee 1, is responsible for most of the standards around computer technology. Not all of them, but most of them. So there's this hierarchy, and there's this committee, and down here at the bottom is the committee that writes the database language standard. The SQL standard has been around for a few years. The initial version of the standard was published as an international standard in 1987. And there have been revisions in 89, 92. The most recent revision was published at the beginning of June of 2023, this year. And the biggest changes there are support for property graphs in SQL and JSON enhancements. I'm going to ignore JSON, and I'll come back to property graphs in SQL in a bit. But first, and one more slide, but before that, but first, the SQL standard actually includes 11 parts. And the part numbers aren't sequential because there have been ideas for breaking out other parts that then we didn't end up doing, and so on. But part 16, property graph queries in SQL, is the newest part. As I said, it was published in June, and so is relatively new, but there's already industry support for some of the capabilities. We've also been working on another database language standard for a database language that we're calling GQL, which is a pure property graph database language. So you can do inserts, updates, deletes, and queries. You have transactions. For defining the data, we have two modes. One is called schemaless, where you just insert the data, and there's no restrictions on the content. The other, you define a graph schema, creating a graph node type that limits what and controls and manages what data you can insert. The important part about GQL is that it's non-procedural. You tell the database what to do, not how to do it. Property graph databases are relatively new. Like in the last 15 to 20 years. So it's a relatively new technology. There's another style of graph databases that have come out of W3C called RDF style databases. And I'm not going to get into the comparison of property graphs and RDF style databases because that's good for about another hour of talking. But the idea is that you have nodes, which are sometimes called vertexes, and a node has a set of labels and a set of properties. And then you have relationships, excuse me, that are stored. And the edges or relationships is the important difference between SQL and GQL. In SQL, you store data that allows you to relate tables. But when somebody writes a query, they have to include that relationship as a part of the query. In a property graph database in GQL, you can store the relationship as data. And so you can write queries when you don't know what the relationship is between the data. So the relationships are tracked in the data. Common examples of this are financial analysis, or doing things like tracking money transfers, looking for money laundering type things, bill of materials. There's some different types of data analytics that you can do with property graphs that are not easy to do with SQL. And the property graph capabilities have been showing up as in support of machine learning, AI, and large language model type things. So they're slightly different than SQL databases, but they do have their own niche, and that niche is a growing niche. An insert, to create data, you do an insert. You can insert, in this case, I'm going to insert a node that is a pet. And I used this example for the first time a year ago someplace, and somebody complained that I didn't actually have a picture of my dog, so I've added the dog to this slide since then. So I'm inserting two nodes. One is a pet, one is a person. And then what I'm going to do is to do a match of the nodes when I have a first name of Keith and have a name of Winifred, and insert a relationship that says that essentially that Keith has a pet. Then I can write queries. Find all the nodes with one hop relationship to Keith. So I'm finding everything that has all the nodes that have a first name of Keith, and then have some relationship. So B is the relationship in the square brackets with some other node. And so the results in this case are that there's a node called HasPet with Winifred, and I've also added a relationship that says Keith has lived in a city called Granville, Ohio. But I didn't have to know, I just had to know that there was a relationship. I didn't have to know what the relationship was. And this is formatted in a particular way. The GQL draft does not actually specify the format of the return data. This could be represented visually as a graph, and how to represent data is a whole nother topic that I'm not going to try to cover today, but it is an interesting, how you represent data is an interesting field of study. I can modify data, basically match data and set a property. I can match data and remove a property. And I can detach and delete. The detach removes the edges, and delete removes the nodes. If a node has an edge attached to it, and I don't do a detach, then the delete fails, because that would make the data inconsistent. GQL supports transactions. And if you look at this slide and you compare it to the early one about SQL, you will see that they're identical, because what we've done in the GQL standard is we have, whenever possible, we've used capabilities from SQL, from the SQL standard. So GQL implementations are going to support transactions the same way that SQL implementations support transactions. Now I mentioned that you can create graphs in a schemaless where you just start inserting data. This had some real benefits in flexibility in that you don't have to know up front what everything is going to look like. You can start storing data and figure out later what relationships you have, what nodes you have. You have to be a little careful because this can lead to chaos. And there are advantages to doing upfront design, but there's also a lot of advantage in the flexibility of just being able to start storing the data. The alternative is that you can actually create a graph type. And what that does is it restricts the contents of the data so it matches the graph type. So the graph is constrained by the graph type. An example of the language to do that, I would create a graph type with some edges and with some nodes. So I've got 3 nodes, a couple of edges. I create a graph that is of that graph type. The first 2 inserts will work. In this example, this third insert will fail because there's no node in the graph type there's no edge in the graph type that allows for this. And so I can use a graph type to constrain what the data looks like, what data gets stored, to enforce rules about what data gets stored. The official designation is that this is 39075 information technology. It's being developed by my committee, WG3, and it's a full database language. One of the important parts, I think, about the work we've done is that the queries use the graph pattern matching language, which is common with the new part of SQL, SQL PGQ. What products adhere to GQL? At the moment, none yet. But there are a number of property graph products that have some GQL capabilities, and so I would expect in the near future, once we actually are able to publish the standard, we will begin to see property graph database products claiming conformance to the standard. So there are companies that are working on this. The project to do GQL was approved in September of 2019, so a little over 4 years ago. We had a draft international standard ballot that closed in August, and the ballot was approved, but we had almost 500 ballot comments. As of our meeting a couple of weeks ago, we have resolved all of the comments, and we're currently waiting for the editors to finish making the changes that we approved. The next step is what's called a final draft international standard ballot, which we should be able to get started in early December. So I think in probably March, we actually will have a standard published. There's a little bit of work to do after the ballot ends, and it takes ISO some time to actually to publish it. And I want to come back to SQL PGQ and graph pattern matching, because we've been doing work in that area for SQL. So relationships are represented by storing common data. The person writing the query has to understand the relationships. So what we've done for SQL is we've added a new part, and essentially what you do is you define a property graph view on top of existing SQL tables. And then you query the property graph view in an SQL from clause. So the benefit of the SQL PGQ part is there's a lot of power in the property graph query language concepts. There's a lot of data in SQL databases. And so what this does is it brings those two things together and allows a company that has, or an organization that has an SQL database with a lot of data, to build property graph views on their existing tables and present it as a property graph to get the benefits of the power of the property graph query language. So if you were to do a Venn diagram, the graph pattern matching portion is common between the SQL and the GQL standards. There's some other things in that are part of PGQ, but we have this common shared language. What's the magic to create a property graph view? In this case, I'm creating a property graph movie rentals that has a couple of vertex tables and a couple of edge tables. And essentially this is taking the relationships that are in the data and writing them into the views, and I can then treat the view as a property graph. So for example, I can do a select star from graph table, and the contents of the graph table is the graph pattern matching statement. And I'm not going to go through these in detail other than to say that this is actually work that is now showing up in product, and I actually borrowed these examples from a presentation by a couple of my standards colleagues that work for Oracle. So comparison, PGQ provides property graph views and sits on top of SQL. And it does not support schema flexible graphs. You have to have already defined the SQL tables. GQL is a full database language and supports either schema fixed or schema flexible. The important thing is that we've maintained the graph pattern matching language so that that part of the standard is identical between the two standards. A couple of examples. I've got a student's graph, and I'm going to do a match, which essentially is selecting things. And in this case, I'm going to find people that are friends with another person whose name is Alice. And the parts in blue are the parts that are the same between SQL PGQ and GQL. So the things that you wrap around the query are slightly different, but the actual queries are the same. Now, SQL PGQ is read-only from a graph point of view. You can't update the graph. You can update the underlying data. You can also get fairly complex. I've got a couple of examples here, but I'm not going to go through them in detail. The first example looks for persons that have, or nodes that have either the person label and either the employee label or the intern label. So you can have a complex label expression. You can do path pattern unions and multi-set alternation. And these two slides could be expanded into a another hour-long talk. But what this means is that you've got a really powerful language for looking for patterns in the data. And there are a couple talks around that are beginning to describe examples of using the power of this. But you can use this level of query now on top of the property graph data and on top of SQL data. So it's common. At the moment, we're beginning to see SQL PGQ implementations. Oracle has version 23C, which is, I don't think it's been released yet, but they've released beta test versions. There's a product that you probably haven't heard of called DuckDB, which has, at least it has a prototype of SQL PGQ. I haven't looked at it in detail. DuckDB is a startup company based in the Netherlands. And I don't know a huge amount about the database itself, but I know that they've been experimenting with property graph work. I know that PostgreSQL has talked about implementing PGQ. From the people I've talked to who work on Postgres, it hasn't happened yet, but it definitely is something they're interested in. All right, what's next for the committee? A number of years ago, I realized that when the committee meets informally, like going out for a drink or for dinner, we often talk about technical issues. And so I started recording notes on napkins, something that I've called the napkin of things. And this is my latest. They didn't actually have paper napkins at the restaurant this particular night, so I was using a doily from underneath something. But it's some of the things that we're talking about for future versions of the standard. And as you might guess, within the standards world, we're looking at AI and large language models, because there is interest in doing that. Now, we already have support in SQL for multi-dimensional arrays. And one of the things that we need to look at is how can we turn that support into like vector queries support in SQL and GQL to support some of the AI techniques. There's a lot of work with JSON, et cetera. Anyhow, this is sort of an informal way that we track ideas that we talk about. All right, one of the questions you might ask is, how do database languages affect you? And it depends some on whether you're a computer science student, somebody who's working in information technology, or somebody who is completely in other fields. What the database languages mean, what the standards actually mean, is that database products more or less adhere to the standards, and so you have tools that use various database products. You have employees that can move between different database products. And so the knowledge is transportable. The tool market around database is transportable. There are interfaces for putting databases behind web pages, and that's reasonably transportable. So if you start looking, what you'll find is that database products sit behind a lot of what you do on a day-to-day basis, although you may not actually notice it. To some extent, if you're outside of the database world and you notice that there's a database, it's probably because there's an issue. And generally, doing database administration, you don't want to see that. But behind banks, behind insurance companies, behind stock markets, there are databases. A significant number of them are SQL. So, to summarize, the SQL standard, we've gone through 9 editions. We've incorporated a lot of new features over time. And it provides consistency across database products. This is not 100%, but it's enough to be useful. We just published a new edition where one of the important pieces is a new part for property graph queries in SQL. The GQL standard is new. It's a full property graph database language. It's almost complete. Actually, there will not be any technical changes. There may still be some editorial changes. And it's targeted for publication in the first half, maybe the first quarter of next year. One of the important things between these two parts is that we have coordinated the graph pattern matching language between the new part of SQL, SQL PGQ, and GQL. And so what that means is somebody who is working on SQL can begin to learn to take advantage of the new query capabilities and take that knowledge and move into GQL databases. So that's what I have. Are there any questions at this point?
Thank you so much for presenting, Keith. It's been really insightful. I'm sure have been learning a lot about the importance of standards in both languages. So if I could kickstart with a few questions that I had from your presentation, get the conversation going. From somebody who is just starting to learn about databases, what do you see of some of the benefits of using a standardized language like SQL and JQL?
The from the standpoint of a database user, the benefit is that you can start working on product X, learn how to use it, pick up that knowledge, and with a few changes, move to product Y. The advantage for a IT department in a company is that if you hire somebody who knows product X, but you're using product Y, then you can bring them up to speed relatively quickly. Changing out a database that a company is using is a technically challenged problem. It's still possible, but because the pieces are the language, the queries, the programming is close, it's actually possible to do. So that's the advantage for users, for individuals, and for companies. For database vendors, the advantage of adhering to a standard is that you don't have to develop it all yourself. You can look at the standard and pick up the language from the standard, and you don't have to develop it yourself. Starting 15 years ago, there was a whole area of databases that were sometimes referred to as NoSQL databases. And it started off meaning that it was a rejection of SQL. But one of the things that happened was that if you had a database product that you said was NoSQL, but you needed a query language so that users could write complex queries, you ended up having to build a language. And by the time you got done building the language, it looked a lot like SQL. Excuse me. So the database movement that started off with calling themselves NoSQL has sort of morphed over the years into not only SQL, where they support SQL type queries, but maybe sorted in a different way. So it gives more consistency to the database industry, to the database, to companies that use database products, and to individuals that learn database products.
Thank you. That's a fascinating story of ending up reinventing the wheel. I had one question also as you were talking about SQL and GQL, and GQL being newer. Do you see a future in which GQL could replace SQL or take over? Is that possible? Is that intended? What do you think?
I don't think GQL is going to ever replace SQL, but it's going to, because it gives different ways of querying the data, it has some real power that is going to pick off some types of applications that are currently being done in SQL. There's a whole host of queries that just are not as easy to do in SQL. In the appendices, I have a couple of links, a whole variety of links, but I have some links to some work that was done by the International Consortium of Investigative Journalism on something that they called the Panama Papers, and then the Pandora Papers. And basically what happened was that somebody leaked a bunch of documents to the investigative journalists from a law firm in Panama. And so what the journalists did is they loaded all of this data into a property graph database because that allowed them to store relationships about this money came from organization A, which was owned by organization B, which is owned by organization C. And then they could write queries about the data to see the relationship and trace back from tax havens in Panama to tax evaders in a whole variety of countries. And so there's that kind of thing that just is not easy to do in an SQL database. So there's a whole host of things that are going to move into property graph databases over the next couple of decades.
That's a fascinating story of uncovering world-breaking news through database queries, and how new technologies can enable such searches and uncover big news stories. Now I have a question from perspective of a young international affairs students at the Elliott School. Let's think about from their perspective, looking up to you as somebody who's been an expert in the field and involved with an international organization. What do you see of a pathway, of a career path for someone and still in school to become a international expert in a technical field like yourself one day?
I'm not sure I'm the best role model, because my model over the years has been to do stuff that I thought was fun. So I got into the standards because I was doing database work and the standards looked interesting, and I hung around long enough and I got talked into becoming the convener of the process. And so, but through my career, most of my decisions have been made on, that looks like it's interesting, that could be fun. So I haven't started any multi-billion-dollar companies. I haven't. You'll find a few technical papers where I'm listed as one of the authors, but I haven't written any best-selling books. So I don't know. I guess you poke and learn new things, and follow whatever fits with what your path is. And my take on it is to have fun, but remember that I do standards for fun, so maybe I have a weird sense of fun.
Well, that's very inspiring, in a world in which you're bound between duty and passion, between something that the world thinks that is useful and important, and something that you find yourself driven towards. Now, also from wearing a international relations hat here, can you share with us any stories of international understandings or folks coming from different backgrounds around the world trying to come to an agreement when it comes to standards like these? Maybe some stories from your time with the committee, where two people from different parts of the world maybe thought differently or surprisingly alike about a certain product or standard.
For a committee that is made up of people who work for different vendors with competing products, who come from different national backgrounds, we tend to get along fairly well. We've and this is deliberate and has been sort of the way the committee has worked since before I got involved with standards. We try to have a culture where we can disagree about technical issues, argue in the meetings during the daytime, but still go out and have dinner together. And that, one of the things it does is it allows us to be, individuals to each other. Now, the other side of that is that the number of colleagues that you can explain how the standards process works to is relatively small. And so we have this sort of common bond that that we do standards, and it's difficult to explain, and a lot of people don't understand it. Now, one of the advantages of having international participation is, or one example of an advantage, is that a couple of people in Japan over the years have translated the SQL standard into Japanese. And anytime they do that, they find a whole host of places where the standard is somewhat ambiguous or where there are errors. And so just the translation process of translating it improves the standard because it finds problems. So that's not quite an answer to your question, but close.
Well, thank you for sharing that. And we do see that oftentimes that issues can bring people together more than not, especially on niche topics and technical fields in particular. Now, trying to bring a little bit of the hype of AI into discussion here. What are some of the biggest challenges with big data and the push for big data and these language models that you've seen, that the committee has been talking about, that's been challenging to you?
Well, on big data, one of the challenges that I've seen over the years is that the term big data has been used as if it were magic. Big data is we can solve this problem with big data. Well, it turns out that big data is just data. And the techniques that you would use when you have large amounts of data are things that we've built into SQL, into now GQL. Another challenge of big data is that I've found that people were often thinking way too small on things they were calling big data. They were calling things big data when it was bigger than what they could handle with whatever computing environment they had. And so they were trying to find ways to make their computing environment bigger to handle more data, but still putting limitations on it. In the GQL standard, we have optional data types for things like integers with 256 bits or floating point numbers with 256 bits. And we have that not because we expect anybody to do it this year, but because we expect that somebody in 5 or 10 years will be need that size of numbers. So we think we have the foundation. We're doing what people are calling big data, but remember that big data really is something that's bigger than what you're doing today, whatever that is. There's been a certain amount of hype about AI and large language models and things like ChatGPT. And the question is really, that's great. You can go off and find a text generation engine that has AI behind it, but can you use your own data to drive some sort of engine for doing problem solving, for doing automated responses, for doing predictive maintenance type issues? Can you build that into your existing applications? And that's the area that I think that the standards will be able to work in. And it all has to sit on data. You've got to sit on, you have to have the data behind it there someplace. Now in the standards world, we're in SC32. There's another subcommittee, SC42, that is focusing specifically on AI type techniques and has been for a number of years. And we haven't done this enough, but we need to coordinate with that committee to understand what we need to do in future versions of the SQL and the GQL standard to support the work that they're doing.
Oh, another technology that comes to mind is distributed ledger technology. Does that present any challenges to database standards or no?
Well, the question is, what do you store the distributed ledger in? And we've looked at this some and haven't come up with any new requirements specifically for that. I think it was 6 years ago when we first started looking at the distributed ledger blockchain type technology. And my assessment was it was the technology that was going to generate the most new books. It's a useful technology, but you have to understand how to use it, how to benefit from it. There's been a lot more hype than actual delivery of useful things. That's my opinion on the distributed ledger type technology.
Okay, if there are no more questions in the chat or the Q&A, I would like to thank you, Keith, again for your presentation today and for the wonderful discussion that we've had. And wish you all the best in your work with the committee and bringing up new standards to respond to modern technologies.
Okay, thank you very much.